And we've still got people coming in, so give everybody just a couple more seconds um, to join us and get settled. Okay, well, welcome again to another one of our Zoom informational meetings. Of course, I'm Kara, familiar Hernandez Darling, and today I'm super excited to have Impang with us. This has been a long time in the in the making and the discussion. Most of you know who M is from our community. They are an engineer and a co-founder of OpenAeros, and pretty much an expert in just about all things air quality, um, filtration, ventilation, UV, lots of other things too. But I'll let them go ahead and tell you a little bit more about how they came to this co-living space and all of the really cool community-based projects that they're heading up and involved in. We will take questions sort of interspersed through the chat. So as you go along, M has decided to pause for different question intervals. So you'll just type those in the chat and then we'll read them out. But without further ado, I'm just going to let M go right ahead.
Hi, everybody. Can you see my screen?
Yep, you're good.
Yes.
Awesome. So hi, everybody. I'm M. I am the one of the founders of OpenAeros. We're a small open source, low cost aerosol science company here in St. Paul, Minnesota. We make low cost open source condensation nucleation particle counters, which obviously many of you like very much because they're used in quantitative fit testers and other kind of aerosol equipment like that. So OpenAeros is interested in taking tools that used to cost, $20,000 or $50,000 and making those a lot more affordable by an order of magnitude or more. I founded OpenAeros with Aaron Collins, my much more famous and well-known colleague, known as the Mask Nerd, and you guys know him from testing masks and doing all that outreach all the time. Aaron and I also founded the Oslov Project. We're a 501c3 nonprofit focused on clean indoor air, obviously with a focus on FarUVC. And so I was really excited when Kara invited me to kind of share my expertise. My background is, Kara mentioned, is in engineering. I went to the University of Minnesota for chemical engineering and material science and chemistry. And I've been practicing professional engineer my whole career. And I'm really excited to share with you kind of my take on FarUV. I'm calling the talk Practical FarUVC because there's a lot of there's a lot of information floating around out there in papers and all sorts of other stuff. And I'm just wanting to try and distill that down to kind of the important takeaways and the updates on where we are as a field and to try and answer your questions. So without further ado, the important disclaimer, critical thinking is strongly encouraged. FarUV and clean air in general are very new fields. I feel like it's not a week or two that goes by that another paper doesn't pop up and fundamentally changes or questions some of the assumptions that we've held dear, for a long time. So obviously I'm sharing with you my opinions only. Please don't take anything I say as gospel. I am likely very wrong about many things that I'm about to say. We just don't know yet because the science is so new and it's evolving, and I'll show some of that in my talk. So critical thinking strongly encouraged, and sort of like presenting the science and the studies as well as I understand them today, but they're changing all the time. And I really want to emphasize that a lot of this stuff is evolving constantly. Some housekeeping stuff, questions are welcome. Just because this stuff is deeply technical and there's all sorts of minutia, I'm gonna fly through kind of these 6 points here. After each slide, I'm gonna pause for quick questions. I ask that if there's a quick clarification or a quick, oh, what did you mean by this? Please ask that there. And then the main portion of this presentation will be a community Q&A at the end of the presentation where you can kind of ask longer form questions. And if a question comes up, I might punt it towards the end, but I'm going to stay here as long as it takes to answer everybody's questions. So no worries there. Your questions will get answered. And I also like to remind folks that if you have a lot of questions to ask one and then maybe see if anybody else has anything to say before continuing. So with that kind of quick disclaimer and housekeeping out of the way, just a brief agenda. I'm going to just do a quick overview of FarUVC. I'm sure a lot of you are familiar about this. I'm going to talk then about skin and eye safety. I'm going to talk about indoor air quality stuff. I'm going to talk about pathogen inactivation, and then kind of the meat and potatoes. What do we need to think about when we buy and install and these systems, with some do's and don'ts. And then obviously, once we've done this brief overview, I'm going to open it up to community Q&A and go from there. So before I get started, is there anything that anybody has? I'll pause for a couple seconds here. Okay, sounds like there isn't. So just quickly, FarUVC or UV is kind of this portion of the spectrum that ranges from around 200 all the way up to almost 400 nanometers. UVC, which is the disinfecting or pathogen inactivating UV, happens in this range between 200 and 280 nanometers. In that there's kind of conventional 254 nanometer upper room UV, and that's been around since the 30s when Wells and Wells did their work, and is a well-established kind of well understood older kind of technology. And there's the new kind of cool far UV, which are these newer UV sources that are emitting down in this 200 to 235 or so nanometer range. And I'm sure most of you know this, but generally 254 nanometer UV is considered more dangerous because it can affect the skin and eyes. So you sort of have to be really careful about how you dose it and making sure that nobody's overexposed. Whereas with the shorter wavelength, 200 and 235 nanometer UV, is generally considered that it's a lot safer for the skin and eyes, and therefore, we're able to use it in the whole room, whereas in a 254 nanometer system, we'd have to restrict that just into the upper room where it can't kind of get to people and do damage. And then, just briefly, you'll hear me talk a lot about krypton chloride excimer lamps. Those are the majority of the far UV sources. They make a 222 nanometer UV light. And also, to a lesser extent, obviously, the traditional 254 nanometer low pressure mercury lamps that are used in upper room systems. And, a little bit about LEDs, that are being researched as well. I'm just going to pause here, having done a super quick overview on just the differences between two kinds of UV. My talk today will be mainly about far UV. Does anybody have any kind of quick clarification questions that they might want to ask about the differences or any details?
I didn't mention this, but I did want to say to everybody that one of the super cool things about and their work is they're not affiliated with any of these companies. There's been a lot of information flying out from the different far UV companies about what does work or what doesn't work, and basically M pretty much does their work for the community and for us to make cleaner air. And so when they're talking to you about all of these different things, keep that in mind. M is not speaking for any particular brand of UV. They're talking about the actual UV science. So I did want to point that out before you went too much further.
Yep. Cool. What does GUV stand for? That's a good question. It stands for germicidal UV. The EPA actually doesn't like it if you use the term germicidal UV, but when the federal government gets their pants in order, we'll see what they want us to call it. But it stands for germicidal UV. But it's a term that's going out of fashion because the EPA doesn't like it. Okay, sounds like that's all. So let's just quickly go over the safety stuff. So until about June of this year, kind of the convention was that for 222 nanometer FarUV, this krypton chloride source, basically the theory was that the proteins in your skin and the proteins in the tear layer of your eyes would absorb all of the far UV photons, so in the dead layer of the skin and in the tear layer, and therefore none of the UV light could reach kind of living cells, and therefore you kind of have built-in sunblock almost to these wavelengths of light. And the nice thing is that while you have built-in sunblock to these wavelengths of light, and they're not able to reach your living cells and cause damage, bacteria and pathogens and viruses and such do not have built-in sunblock, and they're inactivated very, very strongly by these wavelengths of light. So I just wanted to show here that there is a wavelength dependent kind of safety curve where it's generally seen by the industry, and we can get into details later, that wavelength in this 245 to 300 nanometer range are more dangerous, or 240 to 300 nanometer range are more dangerous, and therefore you are allowed to be exposed to less of it, whereas these shorter wavelengths, especially at 222 over here, are considered to be safer wavelengths of light, and therefore the safety limits are higher for those wavelengths. Unfortunately, that a lot of this theory kind of went out the window. So basically in June of 2024 this year, Manuela Bonanno and the team at Columbia University basically found that the tear layer doesn't really do anything to attenuate the transmission of UV light. And there's a group out in Germany that's also kind of starting to see a little bit of funny chemistry happening in the skin from far UV light. So kind of the old theory, which we were going on, is kind of starting to have some issues that are being raised by academics. Unfortunately, that was last month, and there's not been a lot of great research. It's just a new discovery, so we don't really know where the TLVs or the limits need to be reset. They probably do need to be lowered a little bit if you talk to Dave Sliney, who is the scientist who kind of came up with these curves, but we don't know where they need to be reset. However, having said that, the damage and this kind of chemistry that's being observed is happening at such high doses and in such low amounts that we still probably and kind of generally think that far UV, as it is used by our community, is largely safe. But I just bring this point up to highlight that there's a lot of uncertainty and development in the field around the safety stuff. And unlike what manufacturers would tell you, I think the scientists will say it's not, while they would personally feel it's safe, the science isn't fully settled. So this used to be our old theory, but there's some issues with that theory, and more research needs to be done. However, having said that, and that may be sounding a little scary, the research that has been done on safety so far is really very encouraging. Basically, this damage is only seen at extremely high doses. And there's been a lot of studies that have shown generally that stuff is well tolerated. There are a few studies that are coming up that are starting to raise some safety questions about skin and eye stuff, but generally I think the consensus is that the technology is safe, with the caveat that this is mainly filtered pure 222 nanometer lamps. Unfiltered lamps that emit lots of 254 nanometers are a different issue. And Kenny Woods and so on have found that there is some damage from unfiltered lamps. So I know this are kind of interesting sort of conclusions. So I'm going to pause here for questions. Kara, I see there might be a few questions.
Yeah, you've got multiple. Are the thresholds different for kids or pets?
So the answer there is we don't know. And more studies have to be done. Currently, thresholds are not different, but we don't know, and more studies have to be done, and it's very expensive. And with the pandemic going away, there's not that much funding to do these studies. People think that they're okay, but there's concerns about different skin types or different skin conditions, or as you mentioned, infants or different animals, etc. So we don't know. Probably fine, but we don't know for sure.
Yeah.
Another,
We love
another question?
we love scientists that will say we don't know because that's just the answer sometimes. The next question is, how much do the various droplet sizes that contain proteins protect pathogens from far UV lamps?
We don't know. I'm very sorry. There was just a paper that came out that did modeling of different protein sizes, of different droplet sizes and all that kind of stuff. But it's extremely difficult to model and to understand. People are doing research about it, but we also don't know for sure. The consensus obviously is that if the droplets are super big, that might reduce the penetration. So you might see a tiny virus be much more sensitive than a giant bacteria, for instance, but we don't really know for sure, unfortunately. It's thought to have some effect, but it's still thought that, within the respiratory aerosol size around a micron or so, that we're still, in the kind of Goldilocks region where there's good efficacy, but we don't have solid one-to-one evidence. And there is modeling that's coming out, and I can share the paper with you, but that's a rabbit hole we shouldn't jump into right now.
Right. Is there any way a user can check that their lamp is filtering correctly? Is there like a double check that on the user end?
Um, I will punt this question to slightly later in my talk when I get to this.
Okay.
Yeah.
Is the year of continuous exposure mentioned in your slide? What is that at 222? Is that at 200? What was that?
222.
222. All right. And then there's the question if 222 is optimal for inactivation versus safety, or why is that the wavelength most common versus say 208?
Well, 222 is pretty good for inactivation. And there happens to be a convenient excimer line there from krypton chloride. 208, you'd need to use the krypton bromide lamp, which people tried to do. Unfortunately, they're really a pain in the butt to get working. So 222 is kind of this optimal safety plus efficacy, plus like you can actually make the damn things reliably. It's sort of an engineering optimal as well, not just for safety and efficacy. I think if you talked to the wave a magic wand wavelength people, I think they wanted a little bit longer at 230, but 222 just is convenient.
That's cool. Do we know anything about the impact on the skin's microbiome?
There have been some studies, but the thought is that it shouldn't be too terribly bad because you're continuously kind of inoculating yourself as you kind of go about your day. And so it's thought to not generally have any horribly deleterious effects on the skin's microbiome.
Right. How do peptide bonds provide protection, and is the radiation ionizing?
The radiation is not ionizing. It's not kind of like gamma rays or something like that. However, there is this group in Germany that's sort of seeing kind of secondary kind of emission sort of effects where 222 is coming in, it's doing some chemistry, creating a reactive species, and then that reactive species is hours or minutes later doing something else. We don't know. And that's also at very high doses and kind of, new science. They haven't really published their data yet. I'm not sure how the peptide bonds provide protection. Maybe we can talk about that later. I'm not sure if you are meaning to the skin or to the pathogen. So we'll punt that one for later. So I think that's all. So I'm going to move on to, when you say high dose, what number is that referring to? Like doses substantially in excess of the ACGIH limits. So there's also a question about indoor air quality and safety. It's just a fact that UV light generates a small amount of ozone by the photolysis of oxygen. The problem is these small amounts of ozone can then react with volatile organic compounds in the air, things like limonene or squalene, which comes from people, and then these kind of reactive compounds can kind of do undesirable chemistry. You don't want a bunch of reactive stuff forming in the air, because obviously they can create nasty stuff that you don't want to breathe in. And then under certain conditions, these secondary organic aerosols that form can kind of agglomerate together and do new particle formation and increase the PM2.5 pollution in the air, which is obviously not a good deal, for anybody. We have seen this, in Jose Jimenez's paper, Peng 2023, that this does happen. And we also see this in the MIT paper from Victoria Barber and that group. But the good news is that happens at much, much higher fluences in sealed chambers, at sort of conditions that you wouldn't typically expect to happen in the real world. However, we have seen it in the real world. Actually, Aaron Collins saw this when he had a UV lamp in his hotel room. And his hotel room, he was in the DoubleTree Hotel, and they use a lot of perfumes to make the hotel smell a certain way. And there was low ventilation, and he had a UV light, and he did see not only ozone formation, but he saw this particulate matter and undesirable species. So it's mainly an issue in areas with extremely high volatile organic compounds. So that's like if you have an air freshener or scented candle or perfumes, and with low ventilation and low filtration. The good news is that these kind of harmful air quality effects can be easily fixed by using a portable air cleaner, activated carbon scrubber, or opening the window, et cetera, et cetera. So it's a pretty small effect. It is definitely there. It definitely happens, but you can fix it easily. And I don't think you should, in most cases, if you can, be running a 222 UV light without a portable air cleaner anyway. So that there's a way to kind of to address these issues, which is ventilation and filtration. And you'll see here, as soon as Aaron turned on the HVAC in his hotel room, the problem basically went away. So you can in fact see not just the problem occurring, but also the solution. Yes, I'm going to stop here for questions. Okay, so sounds like they're not a huge number of questions, so I'm going to move on. Efficacy. So we've talked about safety. Now let's talk about the efficacy, which is the ability of the UV lamp to inactivate pathogens. So Dave Welch, again at the Columbia group, as well as the groups in Leeds, Kenny Woods, Iwanidi, and so on and so forth, and Kathy Noakes have determined in their experiments that for various different pathogens, FarUV is really pretty good at inactivating various pathogens. And so this has kind of been shown in a small scale in the lab, and you can see this is 1B here, kind of a small scale experiment, as well as in larger scale chambers. So 1B is kind of Welch in Columbia, and 2B is in Leeds in the bioaerosol chamber, kind of at full scale. So there's good efficacy data for FarUV. We do see that it does inactivate pathogens in the laboratory. The question is, we don't know how much it inactivates. So there's this concept of K, which is an inactivation constant. Basically, the higher the number of the K value, the better the UV light is at inactivating or killing the pathogens. And you see across the data set, and I'll get into some examples of this later, that there's variances in K from 0.1 all the way up to 100. And since this is a log function, that's a very substantial disagreement in how effectively this works. So the value of K varies greatly. We need more data. We are actively working on designing experiments and setups and all that kind of stuff to get better data. My nonprofit Oslov is heavily involved in this, but we don't really understand why there's such a big variance. There's a lot of theory, but I just wanted to say that while we know it works and we found that there's good evidence of it working in the lab, For instance, in the small chamber, we find that K is on the order of like 10. And in this big kind of rooms, we find that the K is closer to like 20 or even 100, right? And that's such a big disagreement in the data. And that's indicating that there's more that we don't yet know and need to find out and do research on. Is there any data on influenza? I'll get to that later. Yes, there is. Is there any other question? Okay. So, and then finally, the difference between efficacy, which is does the technology or does the light inactivate you pathogens? Yes, it certainly does. Effectiveness is sort of like the next question, which is okay, if we put UV lights in places, do we improve disease, or do we reduce sick time, et cetera, et cetera? And this is really, really very notoriously difficult. There are a bunch of studies right now that show that things like days off and sick time and absenteeism in schools reduced by about 20%. But a lot of the data is kind of early. There's a lot of noise. There's, difficulties in experiments. These are really, really difficult things to study, as well as being extremely expensive. So we don't have kind of a gold standard study where I can point you at the study and say, look, this country put UV in all the hospitals and all the schools, and they reduced disease by 30% or something like this. We don't have something like that now. There's small scale studies that indicate, that if you look at kind of sick days or absenteeism or things like this, you see about a 20-30-ish% improvement. But there's not a good amount of data on exactly how effective the technology is. Is the 1 millijoule per cm2 for COVID on surface or air? Do we know if the values are substantially different? The answer is there's data for liquid and in air. Those data disagree with each other. I'm mostly talking about air because COVID is primarily airborne. And yes, there's even in the same media, there's disagreement based on how different people perform experiments. And so certainly across different media, you'll also see disagreement. And I'll get into a little bit of this in a little bit. So we've talked about a 30% improvement is great. Why isn't it even better? We don't know. It could be that to make this happen, right, you need to really cover every single space, right? For instance, a canonical study by Wells in 1941 showed that they had really good results in reducing the measles epidemic, but then they had a follow-up study where they didn't put the UV in the buses, and then they didn't really have that good of an effect later. So it could be something like we really need mass deployment throughout our entire community. And so these smaller scale studies that are looking at one school or one office don't have the power to show that larger improvement because the spread's just happening everywhere else, right? It's not happening in the schools, but guess what? The kids are all riding the buses together, or they're going to a restaurant, so on and so forth. Yeah, so that's kind of that. So now we've talked a little bit about kind of the overview, and I just want to talk now briefly about, okay, so we've decided that UV is a good idea. We want to implement it in our space, and we're going out there and we're talking to a manufacturer, or we're talking to a supplier or an installer. What are the things that we need to ask them, right? And I'll come back to this a lot. So the important things to consider are the output power of the lamp, and that is how much UV is it making. And this is typically represented in milliwatts. So what we care is how much UV light in the spectral range of 200 to 230 nanometers. This is the light that we like because it inactivates pathogens, but it's safe for humans and so on. How much light is that? And obviously, how much does that cost? You also want to know, is that light safe, right? I mentioned about filtered versus unfiltered lamps. So you want the weighted spectral output, which is you take the spectrum or the light that's coming out of the lamp and you compare it with the ACGIH standards for the United States or the ICNIRP standards for the European Union, and you compare it with those standards, and you check according to the standards for safety, what does the light kind of contribute. And I'll show an example of this after this. And we also care a lot about how long is it going to make the light? How long, what lifespan will the lamp? Is it going to last 10 hours, 100 hours, 1,000, 10,000 hours? Something, and we care specifically about how long is it going to make the UV light. I don't care how long it makes the visible light. I don't care how long the bulb lasts in emitting a purple glow. I want to know how long is it making this 200 and 230 nanometer light. Be very skeptical of hours or warranty claims and all this kind of stuff. A lot of these lamps will continue to emit visible light long after they've stopped emitting UV light. So we have to ask, how long is it emitting UV light? Other good things to have are the shape of the emitted light. Do you have a really narrow beam coming out of it, which is less good, or a really broad beam which can cover a whole room? Is the manufacturer easy to work with? Do they give you spare parts? Do they have a helpful customer service? Is the part easy to repair? And then obviously you want third-party validation, certification, regulatory compliance, all this good stuff. And on the right, things we absolutely don't care about. Number one, and this is the biggest one a lot of people talk about, the input power. I don't care if it's a 3-watt lamp or a 12-watt lamp or a 1,000,000-watt lamp. That's not helpful. I don't care how much electrical power is going in the lamp. The only thing I care about is how much UV is coming out. I could have a 1,000-watt lamp make no UV and burn 1,000 watts as a heater, and that's useless. Then I could have a 10-watt lamp make 100 milliwatts of UV, and that's much better. So the input power and the output UV are very, very unrelated, and I don't care what the input power is. I also don't care what the raw irradiance or unweighted spectrum is. Okay, you've given me the spectrum of your light, but how does that compare to the safety limits, right? How does that affect humans, right? We don't care about raw irradiance or unweighted spectrum numbers. And then finally, we don't care about some lamps say they have an 8-foot bubble of protection. Other lamps say we cover 1,000 square feet. But there's so many factors, like how many people are there, how tall are the ceilings, what's the shape of where are you putting the lamp, so on and so forth. So these claims from manufacturers are not helpful, and you want to do your own kind of analysis of your space and not just say, okay, we'll take this lamp, it'll cover 1,000 square foot. Doesn't matter that I've got 300 people packed into those 1,000 square feet like sardines. It's still fine, right? That we don't care about that. So I'm going to pause here for questions.
Yeah, you have a lot of questions right now.
Yep.
So how do you get the information that we do care about from the sellers, from the manufacturers?
You ask them very insistently for it, and you make them give it to you. Now, the issue is getting this information is quite difficult, and a lot of them, and it can be expensive, and they don't know how. But if you sell a product, you have a burden to your customer to give them the accurate information. So ask for it, demand it. It's your right as a customer. Number two, Oslov, my nonprofit, as well as other nonprofits and other independent labs, are publishing data. And I'll show you shortly. We have a website where you'll be able to go on to and look at this information as well.
In
But
general, I'm sorry, go ahead. Didn't mean to
go
interrupt
ahead.
you. Okay. In general, is 2 years the limit for UV light before output degrades? Is there a generalization you can make?
No, there's absolutely no generalization that you can make. Some lamps are good for many years. And again, how many hours a day are you running it? Some lamps will die out in a matter of weeks. It really depends on the manufacturer and how good their lamp is. It's not at all okay to make a generalization. We can get more into this in the Q&A. Next.
Is there a validation or a certification that people can depend on in terms of these products right now? What's available?
So there is sort of UL 8802 from UL gives you a good certification of the safety of the lamp, but it doesn't tell you anything about the output power and the lifespan and all that kind of stuff. But for safety alone, UL 8802, look for lamps that are compliant with UL 8802. That should indicate at least the lamp is safe.
Then your last question is sort of technical. I don't know if you want to have a look at it and see. It's something about a point source lamp and radiance.
We'll talk about that later. I have a cool graph, and we can have fun there.
Awesome.
engineers like graphs. So there's a fun graph. Okay, so look, it's the graph. So this is a sterile ray saber. This unit was provided to a ISO certified international lab, Light Lab Allentown, by Sterile Ray themselves directly. The community paid for half of the testing, and Sterile Ray paid for the other half. And there's just some things that I want to show you guys. I'm not calling out Sterile Ray or anything. This is something our community paid for, so I wanted to share this with you. So some things that you can see here: the input power is 94.48 watts, but the output power is half a watt, right? 0.480 watts. So the input power and the output power have absolutely nothing to do with each other. And so buying a 100-watt lamp, I don't care. I care that we're getting 480 milliwatts of UV. And that's only about 0.5% efficient. So that's something to keep in mind. Most of these lamps are between about 0.5% and 1% efficient end to end. So a 12-watt lamp might only make 120 or so milliwatts at most, and it might be a lot less. And also, you can see here to that question, no, it's not a point source. So you can see this polar plot, and I'll have a tool after this that I can show you that shapes the lamp. The lamp shapes the light as it's coming out. And so what we want to do is cover the room entirely. So we want to consider the shape of the light coming out, and as we design and place our lamps. So let's look at another plot. So this is about safety, and my colleague Lewis made this really cool video. So this is a raw spectrum that comes from an unfiltered krypton chloride lamp. You can see there's a main peak over here at 222 nanometers, but there's also the smaller peak at 258 nanometers. That's no big deal, right? Unfortunately, when you add the this is the ACGIH I limit. When you weight this, you can now see that even these little bits of extra emission here can make a lot of contribution to the sort of the safety limit of the lamp, and that's because of this weighting curve that these ACGIH safety standards advertise, and that's because some of these lamps are the wavelength in the 250-ish nanometer range is much more harmful to the skin and eyes than the shorter wavelength stuff. And you can see that if we filter the light, you can substantially reduce the amount of kind of safety limit contribution. So again, unfiltered light, we weight it. That is the kind of the weighted unfiltered light. And when we add a filter, it kind of pushes down those peaks, and we reduce the safety limits that are involved. I'm just going to play this one more time so everybody can watch it and kind of sort of intuitively kind of see how this works. I'll see if there's questions. Can I get a copy of that report, please? Yes, you can. And do optical filters fail over time? Generally, no, but if you break them, absolutely yes. So, if somebody throws a ball and they crack and all that kind of stuff, of course they do. Some of them might degrade, but in general, they're pretty hardy. They're made of silicon dioxide and hafnium dioxide, and those are fairly hardy materials. Still, you should be gentle to them and not kind of break them or crack them or use aggressive, sandpaper or whatever, that kind of stuff when cleaning, right? Or Scotch-Brite or something like this. Be gentle to them. So let's go on to the next one. So this is kind of looking at the this is an unfiltered lamp versus a filtered lamp, and again you'll see that light in this 250 to 300 nanometer range has a lower threshold, and you can see that 100% would be perfect. More than 100% is a larger contribution towards the safety limits, and you can see that the unfiltered lamp has a larger contribution towards the safety limits, which I'll get to what the effect of this is in the next slide. Can you name one or two devices you use? Can you buy post-manufacturing? Let's talk about those things after this talk. So here's the practical kind of consideration. So on the left, we have an unfiltered lamp. On the right, we have a filtered lamp. Because of all this weighting stuff, you can see that the unfiltered lamp, you need to have, 2.5 meters. So that's about, 8 feet away from you in order to be safe for 8 hours. Whereas the filtered lamp, you only need to have it, about a meter. So that's like, 4 or 5 feet away from you for this eight meters, for this 8 hours. So I'm not saying that the unfiltered lamp is unsafe. I'm saying that in order to use it safely, you need to have it much further away than a filtered lamp. And this might be an issue in kind of, shorter ceiling or smaller room or something like that, because you'll have to be further away from it. Any questions? Is sterile ray filtered or unfiltered? Sterile ray lamps are unfiltered. Okay, so I just want to get through this kind of stuff as quickly as possible. Like I said, it's important to me to get Q&A. But to the question earlier about how long these last, so this is a commercial off-the-shelf lamp. We're looking at a 200 to 230 nanometer UV output. And you can see we turn on the lamp, we let it stabilize here at 100%, and then we run it for hundreds of hours. The pauses here are when we were doing other measurements. And you can see that, it's going to hit 70% of the initial output after about 520 hours or so. And the industry sort of has a standard where which we call the L70, or the 70% output of the lamp. And that after the L70, we say that the lamp is spent, because obviously if you're depending on this for safety or pathogen inactivation, you want it to be, as high as possible. And the critical thing to understand here is that the visible light that's emitted by the lamp will not change, because that's made by an entirely different process. So there's no visible change in the emission, but the output of the lamp is decreasing, kind of linearly as you hit this regime here after the lamp sort of burned in a little bit. So we need to be careful about different lamps from different manufacturers and making sure that they're lasting the amount of time that the manufacturers claim, because obviously if it's 500 hours and it's 8 hours a day, that's only about 2 or 3 months before the lamp needs to be replaced. Whereas some other lamps, you can run 8 hours a day for 3 or 5 years.
Are you going to cover the quantitative cards or the dosage dots or any of those kind of things to help people in?
What about this?
Look at there.
So if you have a very expensive UV instrument, you can make all these measurements, and we are doing so, and we'll publish the data. But if you're at home, what you can do is you can buy these prolampsales.com little dots, and they are chemically reactive. So what you do is you stick this dot on the wall and you place the lamp at some distance from it, and then you basically time the amount of time it takes the dot to change color, and then you can look it up in this table or do your own calculations, and you can kind of guess what the output of the lamp is. For instance, if you had a Ushio B1, it has a 12.4 microwatt per centimeter square, 1 meter irradiance. So if you put a Ushio B1 lamp 1 meter away from this dot, it should change to the first color in 27 minutes, change to the second color in 1 hour and 10 minutes, and then so on and so forth. And if you looked at this, you would be reasonably sure, plus or minus some tens of percent, that your lamp's probably still okay. And these are cheap and affordable, which is why I recommend it. It also probably is not a bad idea to try this on your new lamp, just to make sure that, your new lamp's emitting what you think it is.
What was this called again?
These are UVC dosimeters, and prolampsale.com, UVC dosimeter dots. I'll share this later, and
Okay.
remind me if I don't, so that people can. And it's about, it's like less than $20 or something like that. You only need to buy one pack. There's several of these stickers in a single pack. You don't need to buy multiple packs. Any other questions? These say UVC. FarUV and UVC, sort of the same thing. They're just using different terminologies. These are specifically made for 222 nanometer UVC. Yes.
So we jump to
Um,
safety limit. Are the safety limits boundaries and thresholds, or is it that more exposure equals more risk, but after X, it's much more likely to cause damage?
The safety limits sort of came from Dave Sliney and his folks at his lab, kind of doing experiments and setting lower limits of where they thought that the safety limits are. Basically, if you ask Dave and all those folks, they'll say that the safety limits are very conservative. And rightly so, except the eye limit might have to be changed as we discovered. There's new science coming out, and that's why they're so conservative. And so, yes, the larger of the dose you take, the more chance there is to be some kind of damage. However, having said that, even when people have exposed themselves to ridiculous amounts of UV, it seems to be like more of a temporary sunburn or a scratchiness in the eyes, and not any kind of long-term a damage. But obviously, that's not very well known, so I don't want to speak too deeply about that. Have you been able to validate these dosimeters? Yes. They're not entirely consistent, but as a first order check that is kind of sort of an at-home test, these are okay. We have validated them, yes. Okay, we're moving on. So this is the final kind of thing that I said it's important to consider. This is a Ushio B1, and there's a narrow cone here, whereas this is a Ushio B1.5, and you can see it has a broader kind of sphere of emission here. And you can see that there's even larger spheres kind of being cut off by the graph. In general, you want the light to cover as much of the volume of the room, because what we're doing is we're trying to inactivate the pathogen in the air between the time that it's exhaled by the infected person and by the time it's inhaled by the person who's susceptible. So again, we want a nice broad coverage, and you can do that by putting multiple lamps all over the place, or you can use a diffuser where there's some optical method to broaden out the lamp and increase the coverage, and that has a pretty important effect on the inactivation. Again, it's important to get independent third-party data on these lamps. Here's a FCC certification I mentioned earlier, UL 8802. You'll see that this lamp from Lit Thinking has a UL 8802 certification. And certainly my nonprofit, the Oslov Project, manufacturers, we buy their lamps, or sometimes they send them to us, and we measure them on our setup and make sure that the lamps are performing accurately to their claims. And I will say there's not been a single lamp that has performed according to the claims of the manufacturers. We've always found something different. So it's very important that we get third-party data on these lamps, because it's a new industry, and none of these guys I don't think are malicious, but it's new and the science is always changing. So they do tend to be oversights. And so it's very, very important to get kind of third-party independent validation, whether it's from somebody like Oslov, or we actually as a community pay to send it to Light Lab Allentown. And in the example earlier, there's a lot of stuff going on that the manufacturers even don't know that's going on in their products. So it's important, very, very important to get independent data. Okay, now the fun part. I'm going to pause there to see if there's any questions, and then we can talk about how we want to install these. Looks like I have a question.
There's just is there confidence about long-term exposure at low levels will not cause cancer or other issues?
If you talk to the researchers, like you go up to Manuela at a conference and you ask her, okay, Manuela, what do you personally think? And she's the person at Columbia who did the skin and eye research, and also the person at Columbia who found some of these issues with the tear layer. She'll be like, it's fine. So the researchers personally, when you talk to them, they say it's fine. But certainly there's more science that needs to be done. And, maybe you have a skin condition and are susceptible and all this kind of stuff. The science is really new, new. So in general, I think if you talk to Dave Sliney or Manuela or Kenny, or sorry, not Kenny, Ewan Edie, et cetera, they'll say it's fine, but there's more research that needs to be done. But again, that's kind of what their personal opinion is versus what's strongly shown by the data.
And then again, talking, you may be about to do this when you talk about placement in like use cases, but can you talk about FarUVC in schools? Is
Certainly.
that feasible? Do we need to wait for more developments or more research?
In fact, I have a case study in a school that's about a few more slides after this. So I'll answer your question with my case study after this. That's a great question. If you're using a diffuser or anything reflective, as long as it reflects visible light, is it also reflecting the FarUVC? No. In fact, the most commonly used diffuser is PTFE, which doesn't really reflect visible light at all, but diffuses the far UV very well. However, some things like very, very shiny polished aluminum do reflect visible light as well as far UV. So, but it's not necessarily the case. And then obviously some materials reflect visible light great, but do not reflect far UV. How close are we to getting federal standards and regulation? Very far away. California nearly banned them all, but we were able to argue for them not to do that. But in terms of a federal regulation on like how to do this safely and all that, we're far away. It's early days. Will glasses help protect the eyes somewhat? Yes. Glasses will pretty much stop all of the 222, unless obviously leaks around kind of the edge of the glasses or whatever. In general, the eyes take a very small dose because you're not really looking at the lamp directly. Also, most lamps are installed overhead and you're looking kind of down and straight most of the day. So the eyes, even without glasses, take a very small dose, but certainly glasses do stop almost all of it. Yeah.
And then you have a question about fomite transmission with H5N1 on the horizon. Can you talk about far UV and the impact on fomite transmission?
So it has been shown to inactivate inactivates pathogen on surfaces. Remind me after the talk, my colleague who also helped me with the slides, Vivian Belenki, who's part-time at Oslove, my nonprofit, and part-time at Columbia University, has an excellent spreadsheet. Remind me to link the spreadsheet at the end. There's a list of all the pathogens and what the K values are. Yeah. In general, yes, they will deal with fomite transmission, but it's kind of, it'll take long, right? You have to have the light shining on the surface for minutes or hours. If it's up in the ceiling, and there's certainly UV lamps that you can hold directly over like some inches away from surfaces and disinfect those. Yes.
And let's just go ahead and sort of maybe put to bed a little bit. We'll, in addition to recording this, we'll have group files, so we can upload some of these, reports and documents and all of that into group files.
Yep. So anyway, yeah, I'll add all of this later. Remind me if I forget anything. And I just wanted to talk about like if you're installing it somewhere at an event per se or in an office, there's a lot of minutia about what you want to do is to maximize the amount of volume of air in the room that's covered for the lamp, obviously, right? You want to maximize the path length, which means don't put it kind of up against a wall where it'll travel 3 feet and hit the wall. You want it to travel in the volume of the air as long as possible, because that will do the maximum inactivation. I've added all of these are lamps that we've put places. So you see here, we're putting them up by the ceiling and kind of pointing them all around the venue. Right here, we have them kind of up in the ceiling and again, pointed in the air. Here, the same. And in an office space, again, we have it mounted on the ceiling. And it's very important to break up short range transmission. If you can also put a portable air cleaner, as you can see here and here, it's very, very helpful. In fact, I argue before you spend a single cent on any UV, if at all possible, put a portable air cleaner in the space. It'll really, really help, not just with pathogen removal in the air, it'll also help break up short range transmission and help the UV be more effective. with all this stuff talking about how well UV does at inactivating pathogens as they're kind of floating around in the air for many seconds or minutes at a time, I did want to address one thing, which is short range transmission. UV really struggles with short range transmission. So I did this computer model before this talk. So I put 3 Ushio B1s here. So this is 360 milliwatts of UV light directly above a table. This would be the same as about 1 SteroRay germ buster saber directly over the table. And it's making 5.6 microwatts per centimeter square average isotropic irradiance over the table. This is about 10 times or 20 times more than you would have in a room generally, right? So we really like nuke the heck out of the air here. The issue is that if you have somebody sitting at this side of the table and this side of the table, it only takes about 1 second for the aerosol to transit from X to Y. And that's only about a 42% inactivation rate, even at these really high levels. So in the short range, there's not enough time for the UV to disinfect. And the other problem is if we just put the lamps here, right over the table, what happened if the infector is sitting behind X or Y at another table? And I like to point at this study from Kwon in 2020, the Korean restaurant study, right? So person B was the index patient. And you can see that, based on the airflow in the room, person A and person C, in addition to person D, got it, right? So if there had been a UV lamp on the table over here, right, between V1 and A, kind of over here, it wouldn't really have helped very much because the pathogen is kind of coming from here. And, to say nothing of if the pathogen was kind of behind them. So in general, I don't like the idea of kind of installing UV as this protective death bubble of safety in front of you. You want to get it up and high and covering as much of the room as possible. And, if you're at a restaurant and they don't let you kind of, put things around, I would say put it, on the edges of the table to kind of cover as much of the rest of the restaurant as well as at your table, because it's not really going to do anything for short range transmission, but it does help for long range transmission. Show minimal risk of long-term use. This melanoma. Again, there's 26 papers. I'll please remind me after this to add them to the community stuff. I'll add all the various papers and I'll update you guys as new stuff comes out. So just keep in mind, we want as much as possible to minimize this short range transmission. And guess what? If you had a portable air cleaner, it would be kind of mixing the room up and stirring the air, and it would increase this transit time and give a longer amount of time for the UV to act. And as you can see here, this HVAC system is kind of stirring the air all around. And so if we had UV in here, it would be a longer time before the pathogen made it to the different people. And then finally, it's also important to note that we do need to think about kind of the safety of having a lamp on the table, as I alluded to earlier in my slides. You really don't want to be like 2 or 3 feet away from this thing. You're going to take a dose and you might have some scratchy eyes, and you'll certainly violate the limits. Now, what you do on your own time, I can't say, but as a kind of a professional working in the space, I cannot advise you to violate the safety limits, right? I have to stick to what the recommended limits are. So that's a little bit about that. Yeah. And then finally, I wanted to talk about like what happens if we put all of the interventions that we know about together, and kind of what's the priority level, right? So in my opinion, the first most important thing that we can do is test. If you can test everybody, that's going to remove the pathogen. And if you use PCRs like Cepheid or RAM like Plus Life of Metrics, that's going to really remove the pathogen. And I did this calculation here for the long COVID clinic at the Mount Sinai Hospital. And we can see that, kind of with no PCR testing, just adding the PCR testing, right? Just the fact that all of this is green, immediately after you add the PCR testing, even if there are no masks and there's long contact and all that kind of stuff, because the PCR testing really removes the pathogen at the source, and kind of everything's green and hunky-dory after that, right? Having said that, I don't think it'll be controversial to anybody here. A well-fitted N95, as you can see, no masks versus masks, right, is really helpful. And then on top of that, once we've tested and we've done the mask, we want to do ventilation, fresh air, and filtration as much as possible. And you'll see that the HVAC only case will get you, this amount of reduction, whereas when you add a portable air cleaner like a HEPA filter, it'll get you that. And when you add UV, it'll get you that. So this roughly kind of halves the risks with each successive step that you take. So again, testing, masks, ventilation, and filtration first, and then, kind of we've done all the other stuff, UV as your kind of belt and suspenders, especially when we talk about costs. So to answer the earlier question, I wanted to do a case study on a classroom. There is a classroom here that is 13 feet wide, 20 feet long, and 9 feet high. We put 2 BioAbundance B2 lamps in here. And I use BioAbundance because they sent us the lamps, so I have exact data for them. We can first see that there's absolutely no safety issues. We're good on the skin, good on the eyes. Everybody's hunky-dory. So this setup in a classroom works pretty good. And how well does it work, right? So this is where it gets interesting. So you can see that the efficacy of the setup is on the order of, it depends on which pathogen and which kind of circumstance, but you're looking at, between 2 and 3 or 5 and 6 air changes an hour up to, an additional 30 air changes an hour. And the reason for these plots is that there's a lot of uncertainty in the data, like I mentioned. So you're getting, good 10, let's say 10 or 20 EACH from the UV, which is nothing to sneeze at, but you can see that it really depends on which pathogen we're using, and it depends on kind of whose data you choose to believe, right? Do we need HEPA filtration if the CO2 reading is good, i.e. less than 600? I'm sorry for using the word HEPA. I meant portable air cleaners. I don't think HEPA filters are the best idea. I think, kind of Corsair Rosenthal boxes and clean air kits and Tempest and all that kind of stuff are better. But certainly, if there's a classroom and there's so much clean air in it that you're 600 ppm or better, awesome. But remember that we have wildfire smoke and we have exhaust pollution and all the other kind of stuff. So you kind of have to balance. Are we exposing ourselves to PM, or are we exposing ourselves, like, if to get like 500 ppm in a room, you have to bring in a lot of outside air. And what if it's polluted and smoky and all that kind of stuff? So I would say you need to mix both of those things, and it's dependent on the kind of the place and the application. But in general, I would say yes, have ventilation and also have filtration either in the HVAC system or in a portable air cleaner. Yes. And so to answer that question from earlier, I know the numbers are really small, but you can see that, depending on whose study you believe, it can be, this UV can be giving anything from 0.3 ACH to 30 ACH, right? And the Ks can vary from 0.2 to 21, right? So that's a lot of a difference, and it depends on kind of under what circumstances the study was taken. There's a lot of uncertainty. If you ask me where my professional opinion was, Oslov thinks that it's around 10 or 20, somewhere in here. But that's where my kind of guess is, and this is just a guess. And it is pathogen specific, so this is for COVID. Other pathogens are going to be different, right? We can talk about clean air kits and HEPA, maybe that can be a different talk, but that's certainly a thing we can talk about later. So I just want to finally kind of talk about money and price, because that's important, right? So let's talk about a clean air kits that's going to deliver 410 CFM catter, right, for about $380. So you're talking about 95 cents per CFM, right? Versus this is a $1,500 or so UV lamp. You know, kind of taking that middle ground on Catter where, you know, the K value, this inactivation constant here is kind of in this upper end, you know, 10 to 20 or so. We're talking about $2.84 per CFM Catter, right? And then there's also things like the air cleaner is pathogen and agnostic, whereas the UV is pathogen specific. So COVID is going to do a great job for tuberculosis, maybe not so good, right? There are safety considerations. Again, we think it's probably safe, but you know, there's questions. And then there's, of course, short range transmissions. And then on the negatives for air cleaners, they're noisy. You know, if there's a windy kind of a situation, right? You have 30 kids in a classroom, you need a shitload of airflow, right? And it's like a drafty, blowy kind of place. It's uncomfortable. And obviously you have to change the filters. Whereas UV lamps are of course quiet and they're easier, but there's that unknown lifespan problem. So it's kind of a, there are pros and cons to either technology. Where I would go personally is I would first put this portable air cleaner in a room. And then if I had additional budget and additional wanted to reduce the risk, I'd put another UV lamp in there. And that's what we do in our office in Oslo. This is actually the Oslo office here. You can see there's a UV lamp here. And there's an air cleaner here, and there's certainly more in the room. And then right in the corner there, there's a PCR machine. So we're doing everything. And of course, we have to have the mask nerd wearing a mask there as well. So you know, layering the defenses and layering the protections again is what's most important. So that's the end of my spiel. And now I just want to open it up for questions and for the community to ask me. And I'm going to stay here until you guys are done with questions.
Yeah, and right before we jump into that, can I just go ahead and announce that M has graciously agreed to join a still coveting FarUV discussion group and answer questions there as well. And this is where we can put the files. I just wanted to show you guys. Can you see my screen?
Yes.
Or are you?
Yep.
So still coveting and lightning UV discussion. I'll throw this in the chat. You guys can also join here. We'll make sure that the video gets posted here. Any files that they want to share get posted here, and we'll also be hanging around sort of throughout the duration to help keep educating us about FarUV. So with that, ask away.
Yeah. So where
Go ahead.
can you prompt me as to which ones I
Sure, we're
need?
starting with, are you working with Black, Indigenous people of color and low-income communities to make this technology more accessible for people who cannot afford it?
Yes, absolutely. So there's a kind of a thing that we don't talk about. So we might we kind of have been working on kind of a community built DIY kind of, if you think like people getting together as a community to tape together Corsi Rosenthal boxes, we've kind of been like working on this like, you know, community built 3D printed lamp. So we're kind of thinking about how we might kind of put the files for this and the details and plans on the internet, and to make the technology more accessible to people. So if there's interest, I can talk about that. But absolutely, that's something that's near and dear to my heart. You know, I come from a BIPOC community. You know, my family and my loved ones back home in Malaysia certainly cannot afford this. So it's very, very important to me that we make this affordable. I'm pushing on all the manufacturers aggressively. And like I said, you know, I've kind of been fiddling with this kind of DIY situation at home. And if there's interest in the community, I could share, and we can maybe talk about how we can get something going community-wise.
Yeah, we'll love that. Are
Um,
UV lights and HVAC systems worthwhile?
So the thing about HVAC systems is that you have the same issue as the slide I showed with the table. The air in the HVAC system is moving really, really fast. So you have to put a lot, and I mean a shitload of UV light in there. Providing you put a shitload of UV light in there, yes, it does help, but it's very expensive. You have to change the bulbs. There's a whole rigmarole to it. So yes, it does work, but it's a pain in the butt. Because the air in the system is moving so fast, the transit time is very low. You have to put a shitload of light in there to get enough of a dose to inactivate pathogens. It's probably better if you're doing UV to put it in the room where the air is moving much slower and you use less UV lights, and that costs less money, less maintenance, less headache.
For short range transmission, what do you think of personal air cleaners like wind or pure zone? And maybe you can put those in sort of your hierarchy in terms of whole room versus personal versus UV.
So we've tested a lot of, I wish I had Aaron here. He's been testing personal air cleaners. We've found that they don't really, it is certainly possible to make a laminar flow personal air cleaner that will blow a clean jet of your face and air in your face and significantly reduce the risk, right? The problem is to do this well, is very difficult, and the thing would have to be huge. So some of these smaller personal air cleaners that we're seeing certainly are delivering some tens of percent of reduction, optimistically, but not enough that I would personally, for myself, be comfortable. I just wear a mask. It's a lot cheaper, it works a lot better, but I know there's some circumstances where you can't wear a mask, and so they're some tens of percent effective optimistically. Whether that's good enough for you, you'll have to make a
Decision.
decision for yourself.
How many devices has Oslo tested, and is that data posted on your website? What other reputable places are testing the devices? Since it sounds like the manufacturers are not doing dependable enough testing, or they're not
So-
sharing their testing.
Yeah. So if you go to we've tested a lot. We're publishing them slowly, one at a time. There's like 5 or 6 on there. We've tested a lot more. Unfortunately, what's happened is as we've published data, some of the manufacturers have asked us to take it down for obvious reasons. So we don't want to be too mean to them, right? So we're kind of in this rock or a hard place where if you don't see a lamp on our website, either the manufacturer like told us to take it down, or we haven't tested it yet. So it's a new industry, and it's really frustrating, and I don't want to hurt anybody's business, and they're trying very hard, but sometimes they make mistakes, and we want to give them a chance to fix those. But assay.oslo.org. And if you want to talk to me directly, post it on the group, I can certainly share my personal opinion about data that we might not have entirely fully put on the internet yet.
So is inactivation for a pathogen binary, or does it get weakened with any dose? Or if it floats in front of a lamp and gets a dose but it's not inactivated, will it take less of a dose on a second path to get it inactivated?
Yeah, so it's not binary, and it's not even a clean exponential decay. If you look at L. Hadrol, he's out of the University of in Bristol. I forget what the exact name, but they're Al Hadrol from Bristol in the UK. They've actually done some very clever studies where they levitate pathogens in a chamber, and then they watch them get inactivated and all that. And it's a complex step function where there are multiple things happening that reduce the viability of the virus. So it's certainly not binary. It's not even a convenient like exponential decay like we measure it. It's kind of a complicated step function. If it floats in front of the lamp and gets a dose but not inactivated, will it take less of a dose on a second pass to? Yes. So we think that once you give it enough of a dose, it is inactivated. But what that enough is, like I said, is a multi-step kind of thing. If you want to think about this, maybe there's a bad monster coming over you. If you chop off one of its arms, it can still probably hurt you with the other arm. You chop the other arm off, it can still probably kick you. If you chop both legs off, it probably can still bite you, but at that point it's like not bad. And like once you chop the head off, then it's, so there's multiple things. And each time, the arms are probably worse than the mouth in terms of like being able to hurt you. So if you think about it that way, it's kind of a multi-step inactivation process.
We're going gamer on us. We have enough hit points to inactivate it. Okay, with a sterile ray and an RV, is that better to mount it horizontally or vertically, a corner versus the middle of one end? Can you talk about any kind of placement in a long, narrow RV?
Yeah, maximize. So I would put it up in the corner of the RV that lets it shine across the entire of the RV unimpeded. So if you've got one end with a lot of furniture and one end's kind of more open, I would put it in the open area. And I put it up high and kind of let it shine down, unless there's cabinets or whatever. But I basically go in there and see what's the maximum amount of surface volume you can, of volume you can cover, and what's the longest path that you can give the light, because you just want as much volume with as much light in it to inactivate the pathogen. Bioabundance B1 versus B2.
Yes. Is there a trade-off between power and spread? The wider beam takes longer to inactivate pathogens.
Yeah, correct.
And what time frame should we be aiming for at a social event?
I'm not sure what you mean by what time frame.
So I guess they're asking, do you want B1 or B2? And then I don't know about time frame either. I can clarify.
So if it depends, so it's really difficult. So the B1 is really good because it's really broad and it's diffuse, right? Whereas the B1.5 or the B2 is diffuse, whereas the B1 is not diffuse. So the B1.15, I would say if it's like in a home or something like this, where it's a narrower, shorter room, then you probably want the diffused lamp. One, because it'll help you hit your safety limits, in a reasonable fashion, and two, because it'll sort of spread that light out more. Now, if you're thinking about like a super big like event space with really tall ceilings, then you have the really long path length and you have more room for the light to spread out, right? So you don't need to use that diffuser because you have the space for the light to spread out. Then I'd go B1. So again, it depends on the room.
Right. Sterile Ray claims their lamp is unfiltered, doesn't have a significant amount of harmful UV output. Have you done a spectra to confirm this claim? So is Sterile Ray safe, or does it have too much harmful UV output?
Again, Sterile Ray, we paid for it, and Sterile Ray sent a unit to an independent lab, Light Lab Allentown. We got the spectra from that lab, and Sterile Rays are about 3 times worse for the safety limit compared to a Ushio B1. So it's not that they're unsafe, it's that you need to put a sterile ray about 8 or 9 or 10 feet away from you in order for them to be installed safely. And if you don't have that 9 or 10 feet, then you're going to hit your safety limits and you might get scratchy eyes and these kinds of things. So if it was a small room in a confined space, you probably want a filtered light. If it was a large room in a non-confined space, then a sterile ray. It's again installation specific, but sterile ray without a filter does contribute about 3 times more to the safety budget, right? It costs you $3 of safety budget instead of $1 of safety budget, if you want to think about that per unit of light. So you just have to install it further away and be careful about it.
All right. Are there FarUV devices available in Canada?
Yes. I believe so. I'll post links to them after this. But I know there's a Canadian group working on this.
Okay.
Talk to me about that Canadian lamp. I was talking with some engineers and there's some questions about it.
Okay. Saber's lamp is rod-like, and they give the horizontal spread at something like 160 degrees. What's the vertical spread?
So why don't we just go to here and then go to here. So it's basically kind of from -70 to 65 degrees, kind of in 70, so like about 140 degrees on that axis, and this is about 50 degrees, maybe about 60 degrees on this axis. So that's your answer right there.
All right.
I mean, people really do just want to know, what can I buy? Like, what's safe and effective to buy? But I'm aware there's a lot of, it depends.
Yeah. Right.
So again, it depends on your budget. I know there's some controversy with new kit torches. One new kit torch makes about 20 milliwatts of UV. One bioabundance B2 makes about 50 milliwatts of UV. One Ushio B1, so bioabundance B1 makes about 100 milliwatts of UV, and a sterile ray makes 300 to 400 milliwatts of UV. So if you have a bioabundance B2 at 50 milliwatts versus 4 new kit torches, she sells a kit, $365 for the kit. You actually get more UV light out of 4 new kit torches. So but then they're battery powered and there's other annoyances there. So it really depends. It just, like I said, check what the UV light output in milliwatts is. You don't care what the input power is, 3 watts, 12 watts, 1 million watts, doesn't matter how many watts of UV, usually 20, 50, 100, 300 milliwatts of UV. And then it scales from there. And certainly new kit new kits on the market. They do a reasonable job. Bioabundance, they do an okay job. Luminizer, Lumen Labs does an okay job, right? Lumen Labs is another one. Sterile Ray, like I said, there's some issues with the Sterile Ray in our community. You know, there's some return issues and all this other kind of stuff. But they seem to be okay, provided you have the space to put them far away. Lit Thinking, if you're a hospital or a business, Lit Thinking has all the certifications. They're pretty good. I'm not gonna like be mean to anybody's products, but if I didn't say their name, there's maybe a reason why. But ask if you have questions.
All right, there's about another question about portable air filters. We can do another chat about the air filters. I don't know if off the top of your head, I know you mentioned clean air kits, of course, the Rosenthal boxes. Is there a portable air cleaner that you recommend off the top of your head, or should we just do another chat about the air
I mean,
filter?
I think we should. I think you know, there's a lot, right? Any of the CR boxes or the clean air kits or the new kit Tempest or any of those are great.
Can you put an optical filter on a sterile ray?
Yes. It will be about $100 optical filter. You absolutely can. Like I said, it's probably not worth it. Just have it far away. Just give yourself that 9-10 feet, and you're okay.
Are there other companies that do testing for UVC other than Oslab and Light Lab International? Are there other independent labs that are sort of putting this kind of data out?
Ewan Edie's lab in the UK, they do some testing. They've published some data. There's a European company, I forget what its name is. The problem is a lot of these places, other than nonprofits and academics, charge like on the order of $1,000 to $2,000, and a lot of the manufacturers can't swing that. So there's a lot of places that do these measurements. The problem is they cost money, and usually like the manufacturers will do it once, and then like they'll never check it, and then like, you know, products change and you know, there's defects and all this kind of stuff, and they don't catch it.
Which one do you have in the OpenAeros office? What's the UV lights that are in there?
We DIY'd them, and like I said, if the community is interested, I can put out the 3D files and you can talk to me, or maybe we can get a community build together or something like this. But these are about you know, $400 or $500 assembled, everything in, and I didn't want to pay $1,500, and so I DIY'd it. But obviously I DIY'd it, so there's no support or anything. I DIY'd it.
So yeah, we definitely have plans to sort of discuss some community build ideas, just like people make the CR boxes, having, you know, people come together and make the FarUV, and there's a lot of accessibility issues talked about in the chat, and that's another way that we can help contribute to lowering cost.
And to answer your question, yes, we're actively and aggressively working to find ways to get these in lower income communities. If somebody here is in a community group, or, you know, in an organization, a nonprofit, and all that kind of stuff, do reach out to us. We're a small nonprofit. It's Aaron and I in our spare time, but if we can find a way to help, we will. Yeah.
If you get the optical filter on the sterile ray because you don't have 9 to 10 feet, how close can you be if you buy the optical filter?
So you'll get about a 3 times reduction, 5 or 6 feet.
And do you have a link for that filter or a specification for the filter? Where can people get it? Can you put that in the group later?
Well, you'd have to get it custom made. It's a pain in the ass. Like, don't do it. It's a big pain to get.
I think these are people that already have sterile rays that are wanting to follow your advice about, you know, the distance, and they may not have the 9 feet. So how can you help them then, or what would your advice be for someone? We got a second question.
Yeah, so what you can do is install it so that you're not looking at the eyes directly. So if you can install it with you're going to lose some efficacy if it's pointed down, right? But there's this, in the standards, it says that the eyes look at about 80 degrees. So if it's coming down like this, very little light is actually turning the right angle and making it in your eyes. So installing it face down is helpful, because nobody's going to like look up at the light like that for hours and hours. And then also minimize how long you're looking at it, right? So if I share the screen again, Here we go. So the eye limit, if you're 3 feet away, don't do it for more than 90 minutes, right?
Don't
So
stare at it directly and continuously for more than 90 minutes.
yeah, so like don't have it in front of your desk while you're working or something like this, right? So you can, or if it's, so like, again, this is a time and like and don't like, this is like going to be like 15 minutes, right? So like definitely don't be this close. So again, as long as it's far away enough, you're fine. And here's some of the calculations, and I can post this in a group. Folks, feel free to screenshot this. For sterile rate, this is how far away you want to be.
Do you know
You're kind of screwed.
I think we should put this up we'll put this up in the group file so people can have a look at it.
Yeah.
Do you know the UV output of the MVP Krypton small tabletop unit?
It's some tens of milliwatts. I would guess like 20, 30 milliwatts, somewhere in there.
Yeah. No, we've already talked about
about the same, yeah, very quite similar to a Nuka torch. If the type of the lamp is similar, so these are coaxial lamps, like they look kind of like that donut kind of thing with the metal mesh in it. The output per unit size is roughly consistent. So around that, some tens of milliwatts is likely.
To what extent does FarUV bounce off of interior surfaces? So is it hitting a wall and bouncing off somewhere else?
Very little. Some paints and some aluminum surfaces can be tens of percent, but most times, like a regular kind of matte wall, it's like 5 or 6% reflectance. So like after the first, 90+% of it is gone after the first bounce.
So I knew this question was going to come up. You're at the dentist, you're in a cramped dental room,
Yeah.
You've got your sterile ray in your lap on the wall. You've got your MVP or your new, like, what are you taking with you into the dentist where you have to have your mask off?
We went and found a dentist, convinced them that the aerosol science was important, installed air filters and cleaners, and made the dentist wear a mask and schedule appointments first thing in the morning. And if I couldn't do all of that, which I realize is like a big pain in the ass to do, I know there's pick a time, like you have to see the dentist every 6 months, time it so like be late or early so that it's just happening in the lull of the COVID wave, right? In the summer lull or just after you've been vaccinated. Certainly put the sterile ray or whatever up high and all that kind of stuff. Go first thing in the morning, make your dentist wear an N95 mask, et cetera, et cetera. The more you can do all the other things, the better. Yeah.
All right. And then a lot of thanks for being focused on accessibility and for sharing your time and all of that. So
yep.
Awesome info. So
can we ask about OpenAeros updates? Yes. If there's no more UV questions, I will answer OpenAeros update questions.
So is everybody good on their someone's asking about Krypton Shield or Guard, which you didn't mention.
So FarUV Technologies, as far as I know, slightly went out of business. So that's why they make reasonable products. But they're having some business issues. So I don't know about you, but if I knew a company was kind of struggling a little bit, I wouldn't want to give them $2,000 because I'd be worried about warranty and other things. But they're good products. I'm just they're having hard times financially as a company. So I need to be mindful if I advise the community, about them that, we think about that.
Is it worth testing ozone on site when using FarUV?
You need a $5,000 to $15,000 ozone monitor. You will find a single-digit part per billion increase in the ozone. Generally speaking, opening a window will make the ozone rise more than the FarUV. So it's a concern certainly in very unventilated small spaces, but in generally, I don't worry about it too much. Especially if you've got an HVAC system, especially you got one portable air cleaner in there, I don't even think about it because the portable air cleaner is going to take out much more than the UV could put in.
Any thoughts on PAPRs? That's probably another talk.
Yeah, another
Uh,
call.
yeah, FarUV is 100% in business. The rumors of their demise are exaggerated. Okay, that's another topic too.
I understand that PJ says things, but we've also had a lot of community outreach that, yeah, anyway, we can talk about that later.
How do the Chinese made bulbs from first UVC compare to sterile raised bulbs? Who is making the strongest longing lasting bulbs?
In general, they're both coaxial bulbs and not optimized for lifespan, in my opinion. Ushio makes very, very long lasting bulbs because they do some very, very clever things. Yes.
You can smell when the sterile ray is on in a room. Is that the ozone?
Yes. And if you can smell it, it's likely because there's some something's arcing, or there might be an electrical fault or something like that. If you can smell the ozone in the room, you've got a big problem. Please don't use it anymore.
Can we get your opinion on the proposed ACT standards by Representative Don Bayer? Airborne.
I'm not familiar with those, unfortunately.
Yeah, so it'll be.
I assume they're probably in line with 241p, which we like, but it's a first pass. So yeah. To my earlier point, because it's been so hard to study airborne infectious disease transmission, we have no idea where the heck to put the standards, because we don't know, like what the impact is. And so there's a lot of estimations and people are doing modeling, but there's this chicken and egg problem in science right now, and people are working really hard to figure it out, but it's not fully figured out. MERV 13 and ASHRAE 62.1, that seems very reasonable. I would push 241p on top of that, which I think is a good idea. ASHRAE 241p.
All right. Well, looks like you have exhausted a lot of the UV questions. How fast are costs going down? I think your community build is fastest cost drop I've seen.
They're gonna floor at around $400 to $500 for a Ushio B1 type emitter. So price per milliwatt, whatever, like let's say 450 divided by 110 is like $4 a milliwatt is kind of where they are right now, and I think that's close to the floor. And remember, it's not the companies being greedy or like overcharging for the lamps, and it's not the fact that the lamps themselves are expensive. It's people got to pay their accountant and their admin person and run payroll and pay engineering. It's all the overhead costs, because UV lamps aren't being sold in very large quantities. So if you're only selling at 500 lamps a year, and you've got 3 engineers costing you $100,000 a piece each, an admin person, an executive, blah, 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 all this rent, utilities overhead. That's why the lamps need to cost so much, in order to,
Keep the company in business, yeah.
Yeah, keep the lights on. It's not necessarily greed. It's like, that's what it needs to cost in order to keep the lights on. So once you start to buy more, costs will come down. But I think the floor right now is around $400 to $500, or like about $4 a milliwatt. So a 100 milliwatt lamp, $400, a 300 milliwatt lamp, so on and so forth.
I'm a librarian at a school. Placing Nuket torches facing up or toward me on my desk would be helpful, right?
Just be careful like how far away from your eyes those torches are, and it would be much more helpful if you could put them above on a shelf all around you, kind of in the area that you're working. Like I said, your desk would be shielding the bottom part of it, and if you can get them up high and kind of down and covering all the air, that would help a lot more. Certainly would be helpful, but again, maximum coverage. That's the rule of the.
And in your hierarchy, right? Like you also want to have a mask on, and having an air filter would be even more helpful than having the Nuket torches. So that hierarchy that I think is.
Yeah, if I had only a limited amount of money, the first thing I would buy is a bunch of really nice V-Flexes or Auras, or like a good N95 mask. If I had a bit more money, I'd buy a plus life tester, right? Because it's two things. One, you can remove infectious pathogen by testing people and not hanging out with them when they're positive. Number two, you can catch when you are infected very quickly and get treatment in and rest and get Paxlovid and all this kind of stuff. Substantially improves disease outcome. if I had a little bit more money over on top of that, I'd buy one of those Midea, 200 CFM, but whisper quiet air purifiers that are like 150, 200 bucks. And if I had more money yet on top of that, that's when I would start buying the UV. Or a CR or whatever, yep.
We did talk about fomite transmission, and most of the research on superbugs in hospitals is UVC. A lot of it isn't the FAR22M. It's not going to increase superbugs. It's going to reduce superbugs. But I don't know if you have anything else that you know to say about fomite transmission.
In general, there's pretty good results. There's a European company, UV Medico, that did a bunch of papers where they were putting them in hospitals to sterilize hospital rooms after the fact, and also in ambulances to sterilize. And there's generally good results. You need to expose for hours, but you don't care. The hospital room's empty, right? Turn it off, blast the light, and come back. 2 hours later, it's perfectly fine.
What kind of air purifier did you just mention?
Like it goes, so there's a few I like. I like the Clean Air Kit Sluggables. I like the new Kit Tempest. I like any CR box. Those can be a bit noisy. What is it? There's like, it goes by a lot of name. Like it goes by Laurel. It goes by Midea. It goes by, yeah, there's like it's like one Chinese factory and they have like a bajillion different brands. But it's the one that if you go on cleanairstart.com is like the best one. Check out cleanairstart.com and buy from their recommendations. They do a good job.
All right, I think we're ready for OpenAeros updates.
Can you talk about the PCR machine in the OpenAeros office? Yes, it's a Cephia Gene Expert Express that we bought used on eBay and repaired because we're dorky engineers like that. The cartridges for COVID cost about $38, but you can pool 5 to 10 people per cartridge, which means like that's about, so $30, $38, but pool, let's say we pool 7, that's like a few bucks a test. And the nice thing about the Cephia Gene Expert Expresses is that they will find 30 to 50 copies of SARS-CoV-2 down even from the plus splice, which find about 400. So they're really, really stinking sensitive, and they will give you quantitative results. And we have had really good results with them catching early infections, catching infectious people at the office before they're infectious, and just generally, knock on wood, there has been absolutely no spread of COVID at our office. Despite going to masking optional, provided you have tested and everybody else has tested in the last 2 years, 2 or 3 years, yeah. OpenAeros questions, let's see. Oh yes, the new Air Fanta is cool. I know some people are having issues with fans, but I hope they get those fixed. Rough timeline on reviews. So I want to be clear that the first thing that we're coming up with is the OpenCPC, which is a condensation nucleation particle counter. You can use it to do fit testing, but it's not a fit tester. You can use it to do a fit tester. That should be available before the end of the year. Yes, it has Bluetooth and we'll have Wi-Fi and also USB. We have been doing fit testing with it. It will only do an N99 and 100 fit test. It does not have a DMA, so it will not do an N95 fit test. So if you're wearing a mask like a VFlex, which has less filtration, it'll report an artificially low fit factor. But yes, it will do fit testing, but it is intended as a research instrument. OpenFit is something that we're working on. The problem is that to do OpenFit, we need to spend hundreds of thousands of dollars in order to go to all of the various regulatory bodies and convince them that this works as well as a port account. And we're working on that, but it's just Aaron and I, so that's expensive and slow. We did enter the NIOSH Fit Test Challenge, and if we win that, then it will be much faster to do OpenFit. But so OpenCPC, end of the year, you can use it for fit testing. OpenFit, we're working on it aggressively, but it's really expensive, and that will have the DMA and be able to do N95 mode. Holly, you
questions about that. There's a bunch of questions about that commercial PCR that you refurbished. Refurbishing a professional PCR machine is really not usually in the realm of just general consumers. The Plus Life is the closest you're probably going to get. You're not going to be able to go out and buy a PCR machine and know how to run a PCR yourself. It's not something that lay people do.
Yeah, it's called the Cepheid, CEPHEID Gene Expert Express. You have to do a shitload of paperwork and have a lab license and a CLIA, this and that. And there's a lot of please don't do that. The Plus Life is just as good. We're nerds, so that's why we refurbished the PCR machine. We also have Plus Lives. We use them a lot. Please use the Plus Life. It's great. Unless you're really dorky and you really want to take one of these apart, then message me and we can talk. How many cartridges can
If you
run?
have lab experience and you know how to like PCR things, I would say. Go ahead.
Does
Does-
OpenAeros and Oslo accept donations? Yes, we do. Oslo is a 501c3, so all donations to us are tax deductible. OpenAeros does not. We sell aerosol science equipment like CPCs and hopefully fit testers, and we do so, at affordable prices, and that's a great way to support us. Aaron and I don't believe in pre-orders or any of this other kind of nonsense, Kickstarter, all that kind of stuff. There'll be a page on our website where you can order one of these and we will ship it to you that day, and we won't take your money until that is the case.
For your work policy, do people test with PCR daily and not wear a mask, or every couple of days? What do you guys do?
So we just to be clear, we have almighty amounts of UV throughout the office. We have over 10 air changes an hour throughout the office and multiple air cleaners and filters and all that kind of stuff. People test every other day and they don't wear a mask. And the reason we're comfortable with every other day is because we're using the Cepheid and we know it's going to pick up 30 to 50 copies. So we know that we can guess that the doubling time of exponential growth is low enough so that even if we test every other day, we should still catch it way before it's infectious. And even if even if we fail to catch it, we have so much air going through the space, like it's bonkers, that there should be no infection risk. And so far, so good. People have been asymptomatic in there, like, they come in the morning, they're asymptomatic for a couple hours before we test them. But again, there's never been anybody with any kind of infectious dose of COVID in there because the tests catch it so quickly. We're talking cycle totals in like 35, 40 kind of range, where you need to be like at 27 to be infectious.
All right. I think I'm going to go ahead and stop the recording now. This has been awesome information, and we can definitely continue conversations and compile on the new group that you've so graciously
You are
agreed
still
to
recording, by the
hang
way.
out with. Yeah, so I'm going to go ahead and stop that. Last time I stopped it, like, it was just really abrupt, and so I wanted to make sure I said, bye, everybody, we're stopping the recording now.